Hey community, this is Dr. Hugh, and what I want to talk about today is what I'm going to call cell membrane detoxification. And this is a critical component. I've been doing lots of research and helping people that have chronic illness, chronic disease, and this is a huge missing component. So I think you're going to get a lot of value out of this. Now, if you're watching this on YouTube, if you could greatly give me a thumbs up, and if you could subscribe to my channel would be awesome. I've been on YouTube for, I don't know, over 10 years. I have over 1,000 videos, and this content can help people. I just need some community engagement to help spread the word of my channel. So thumbs up and subscribe to the station. And let's get into this. So what am I talking about when I talk about cellular membrane healing? What we really want to get down to is this right here, is let's bring some common sense back to health. If we can bring common sense back to health, you are going to get better. And when we talk about common sense health, we have to do some education, right? So we're going to be talking about your cell membranes, but not only your cell membranes, is when God designed us, we have 30 trillion cells. So every cell membrane, we're going to be talking about the bilayer in there, and then also all the different organelles within the cell. They have the same bilayer structure. So if you don't have a good membrane, you're going to be chronically inflamed. And all these different components right here have the cell membrane that we need to make sure is functioning optimally and is healthy. So this is your whole entire cell. So what we're going to be spending really time on is the phosphatidyl bilayer right here, and this is the structure of our cells. But not only is it the outer structure of our cells right here, it's also the outer structure of the mitochondria. It's the outer structure of this right here, the endoplasmic reticulum, this part right in here, the Golgi apparatus right here, which is that thing right there. Lysosomes, which are basically things that break things up. Lysosomes, you can see the lysosome right there. And then guess what? The cell nucleus is all made up of this structure right here. So how important is it to have good cell structure? It is critical, especially with chronic illness. Now, I want to read this to you here. So this comes from the internet. So phosphatidylcholine. So this is what we're really going to be spending our time on here, is a product called phosphatidylcholine. It's a critical component of cell membranes, acting as a major building block and contributing to membrane fluidity and function. It is the most abundant phospholipid in mammals, making up roughly 40 to 60% of the total phospholipids. So this is very, very critical. We need to make sure that you have enough phosphatidylcholine in your diet, in your supplements, because if you do not, your cells become crusty and your cells cannot get things out of the cell and into the cell. But not only is it the cell, it's the nucleus, it's the endoplasmic reticulum, it's the liposomes, it's all these different organelle structures within the cell that have this same bilayer. So we want to make sure that this bilayer is definitely healthy. Now in here, you can see this picture right in here. This is just the lipid bilayer, and you can see how they have these two layers that come together, and that is the structure right in there. Now, the product that I'm going to be talking about is what we call exactly the membrane mend. So if your membranes are not well, or if you have chronic illness, not only are your membranes not well, but all the organelles in the cells are not healthy. And this will be the root cause of a lot of people's chronic illness. So you can see in here, it has a massive dose of phosphatidylcholine, 460 milligrams. Now, not only does it have that, but it also has other components in there, astaxanthin, which is an antioxidant. So this is a really cool study right here. So you can see here, this is the phosphatidyl bilayer, right? A layer here and then a layer here. So the outer layer right here is water soluble, and then the inner layer right here is water soluble. So you can see here it says hydrophilic right here. Hydrophilic, that means that it likes water, and then you see the fatty acid. So this is the fat, the middle part is the fat, and then the outside is the water soluble product. And the phosphatidylcholine is basically these little heads right in here. Now, the astaxanthin, that's also in this product right here, the astaxanthin right here, you can see that right there. So you can see this astaxanthin right here. You can see how it goes through the whole entire bilayer, right? So it goes through the water soluble and then the fat and then the water soluble. Now, why is this so important? This is so important because not a lot of antioxidants are fat soluble and water soluble, and astaxanthin is. And what they've shown in this study right here, this, like, you see the astaxanthin and you see these little electrons right here. So the astaxanthin can actually allow electrons to move from this layer right here, the outer layer, to the inside layer. So you see how these electrons are, you can see here, it goes either or. You see all these electrons right here, and they move up and they come out into the outside right there. Now, why is this important? Because electrons are needed for energy production. Electrons are needed for ATP. Electrons are needed for mitochondria. So all these things are very, very critical. So it's an antioxidant, and it also pushes electrons in and out of the cell. Now, this product also has a couple other things in here. It has vitamin E, which is a fat-soluble antioxidant. Fat-soluble, right? So we have antioxidants that can be fat-soluble and water-soluble, and then we only have a very, very few that can be both fat and water-soluble, right? So vitamin E is strictly fat. Astaxanthin is that special antioxidant that is fat and water soluble. So this is where it's really, really critical. This is why it helps these cell membranes so much. And this is the content you want to geek out and see where I got the research. Now, Quicksilver Scientifics. So this is a Quicksilver Scientific product. I've been having some of the most success clinically with chronic illness with Scientifics, with Quicksilver Scientifics. They have patents on the delivery system. So this is a very specific delivery system on how to get these nutrients into your body. So this right here this is another product. This is just pure PC. So just pure PC is this right in here, phosphatidylcholine. It doesn't have these other structures in here, which are very critical as well. Now, I like these pictures. I kind of want to geek out on some of these pictures here. Is you can see what I'm looking at right in here. Is this right here. You see this? This is the cell membrane. Or I'm sorry, not the cell membrane. This is the mitochondria. So you see that layer right there? That whole layer is that phosphatidylcholine, that bilayer. So all the mitochondria are this bilayer, and you need to have phosphatidylcholine in that bilayer to get nutrients in and out, not only to get nutrients out, but to get electrons in and out of the nucleus in all parts of your body. Now, when God designed us, check this out. We have basically 30 trillion cells. And within one cell, let's just take the heart. Within one cell, we can have 2,000 mitochondria. So this is pretty crazy. So within one cell, we can have 2,000 mitochondria. And this whole entire outside of the mitochondria is that bilayer. See these little, what they call these little cristae, these little lines? That is the bilayer as well. And then we have this right here. We have this rough endoplasmic reticulum. So what the heck is that? So if we look way up in here, you can see this part right in here. That's the rough endoplasmic reticulum. Why is that so critical? Because the structures in your nucleus here, the structures in your cell, I should say, just aren't like free floating, hanging around. They have some like structure to them. Just like a house has a frame. So there's a lot of these organelles within the cell that will contribute to making the cell have some kind of structure to it. So in here, this is just another picture. I think these are really cool pictures. So you can see right here, we have the nucleus. So the nucleus, so that whole layer right in here is all that bilayer, phosphatidylcholine. And then you can see what we have here is the ER, which is called the endoplasmic reticulum. You can see how that's just kind of diffuse, holding things together. And all these little lines here have that bilayer. This is why that bilayer is so critical. Here's just some more pictures. I really like these pictures here. So the nucleus, so again, the nucleus has that bilayer. And then we have the endoplasmic reticulum. We have both smooth and rough. At the end of the day, it's just the communication within the cell. We have all these mitochondria. All the mitochondria are phosphatidylcholine, the bilayer. So you can see all these organelles are super critical to make sure that you have enough phosphatidylcholine. And if you have chronic illness, at the end of the day, you're not getting enough phosphatidylcholine. In here, check out the mitochondria. Okay, the mitochondria, again, this has the phosphatidylcholine, the bilayer, the endoplasmic reticulum, that has the bilayer. Here's another mitochondria. I mean, these slides are just really, really cool. Now, I want to geek out a little bit here. So what we have right here is we have this right here, which is the nucleus right here, this whole thing right here. This is the nucleus. Now, you can see this, which is really cool. You see how the nucleus right here, if I blow this up, you see how it actually opens up and produces this is what we call the endoplasmic reticulum. So what happens here, the nucleus itself isn't fully encapsulated. There's a little slit on one of the sides, and then the endoplasmic reticulum starts to form there. So the endoplasmic reticulum literally is just an extension of the cell nucleus. Now, what happens in here? Why is it called the rough endoplasmic reticulum? You see these little bubbles right here? These are ribosomes. These are ribosomes. Now, what the heck happens in the ribosomes? Check this out. This is where RNA is produced, right? So we have DNA and we have RNA. So within the cell, we have the cell nucleus, and then right beside the cell is the rough endoplasmic reticulum, which has the RNA, the mRNA, the messenger. And that is, guess what? That's the phosphatidylcholine bilayer, right? So we're talking about genetics here. We're actually talking about getting down to the genetic code when we talk about rehabbing your cell membranes. So this is a really great product that I've been having success with. This is a Quicksilver. So they have a product right here called Bitters. This helps your gallbladder. We have the kidney support. You got to detox this stuff out with the cell membrane. And then we also have vitamin C. All these things right here are things that help support your cell membranes and decrease the overall inflammation in your cell membranes. And then once you do a protocol right here, then you actually, when the toxins start to come out of your cell, you want to grab those. You want to grab those with some binders. So this is a great binder here. It's called the Ultra Binder. And you can see here that it has a variety of different binding agents in this. You sip this. So you take these protocols and then you sip these things. And this really starts healing your cell membranes. Like if your cell membranes are not healthy, you're not going to be well. If you have chronic inflammation, you're going to be well. If you have pain anywhere in your body, like on a chronic level, your cell membranes are not healthy. And if you've never tried to heal your cell membranes with a specific program, a protocol, this could be a missing link when it comes to your vitality and you getting well. So with that being said, I hope this brought some value to you. And if you want to reach out, feel free to reach out and contact me or us, my clinic. And remember, is where there is help, there's hope. Take care. Bye-bye.